everyone, welcome once again to Physics Me. We're here to continue our business on the concept of measurements. You remember that in the first, second and third video we laid foundation on the concept of measurement. We looked at the concept of quantity, dimension and then unit. We also considered how we can actually find the dimensions and units of derived quantities, and I think we solved one example in our previous video. So today we are going to solve more examples on how to find the dimensions and units of derived quantities. Just follow me on this journey. Make sure you subscribe to our YouTube channel and then follow us on Facebook at Mathematics and Science Me. Thank you. So today we want to move to the second example on finding dimensions and units of what derived quantities. If you look at this, this is concept of measurement part 4. That means we have part 1, part 2 and part 3. Make sure you watch the first part, the second part and the third part, because without that you may not really understand what we are about to do now. Okay, so we are asked to find dimensions and units of the following: speed, velocity, acceleration, momentum and the word force. So how do we go about it? So solution to this, how do we go about it? So solution. Now we say the first thing we do when we want to find the dimension and unit of any quantity is to write the formula that can be used in finding the quantity, and we also ensure that that particular quantity is the subject of formula. So when we want to find the dimension of speed, we need to first of all write the formula for finding speed. We know that speed is distance over time. Speed is distance over time. That's the formula. And in this formula now, speed is the subject of formula. From the knowledge of mathematics, you know what we mean by a quantity being the subject of formula. This speed is standing alone. It's expressed in terms of other quantities. So you write the formula for finding the word, finding the quantity, and ensure that that quantity is the subject of formula. Then the next thing is to express all other terms in terms of the dimensions of the word of the fundamental quantity. So we need to write distance and time in terms of dimensions of the fundamental quantity. So let's do that. We know that distance is the same thing as length. So the dimension of distance is length and the dimension of time is what? T. So this now is the dimension of what? Speed, which I can write in an alternative form. I can write it in other form. I can say that this is length per time, or I can write it as length per time. So this is the dimension of what? Speed. The dimension of speed is this. So this is the dimension of speed. Then what will now be the unit? We replace the dimension by the appropriate unit to get the unit. So what's the unit of length? Meters. What's the unit of time? Seconds. So I can write it as meter per second or meter per second. That's the unit of speed. So the dimension of speed is length per time, which can be written like this, or like this. Why the unit of speed is meter per second, meter per second, meter per second. So that's the unit. So you see, it's very simple. So we look at the second question, the second quantity, velocity. We follow the same approach. We need to find the word. We need to find the formula for finding the word, finding velocity. So what is velocity? Velocity is displacement all upon what? Time. That's velocity. So having written the formula for finding velocity, the next thing is that we have to write all other terms in terms of the dimensions of the fundamental quantities. So we now say, what is displacement? Displacement is length, and time is also what? This t. Time is t. So this can be written also as length per time or length per time. So that's the dimension. So this is the dimension of what? Velocity. So if you look at velocity and speed, they have the same word? Dimension. They have the same dimension. Two quantities can have the same dimension, but that does not mean that the two quantities are the same. Let's take, for example, speed and velocity. They have the same dimension, but they are not the same, because speed is a quantity we refer to as scalar quantity. Velocity is a vector quantity. We'll explain that in our subsequent videos in physics meal. So let's look at the unit of this. Length is measured in meters, time in what? Seconds. So this meter per second or meter per second. So that's the unit of what? Velocity. Okay, we have the third quantity, which is acceleration. Acceleration. What's the formula for acceleration? Acceleration is velocity change divided by time. Now someone will be wondering, how will I know all this formula? Don't worry, by the time you do physics, you meet all these formula in various topics in physics. For example, when you do the concept of motion, you will see this formula of speed, see the formula of velocity, see the formula of what? Of acceleration. So don't be bothered by the formula yet. For now, if you are a beginner, we are just giving you the formula for us to derive the word, the dimensions and the unit. But with time, when you do these topics, now you will now know this formula. All right. So already we are looking for the dimension of acceleration. Already we know the dimension of velocity. Velocity change, we have the same dimension as velocity, and that's the dimension of velocity, length per time. So dimension of velocity change is length per time, all upon this velocity. So this velocity over time, so length per time divided by time. So we need to simplify this. So what does it mean? Length over time, the whole of this is velocity. Remember, we have another time. So velocity is length over time divided by another time. So this means length per time divided by time, which I can write as length per time times 1 over time. This mathematics, when you change division sign to multiplication, you need to invert the number or the fraction after the sign. So if we do this, we're going to have length times 1 is length, and time times time will give me time raised to power what? Time raised to power 2. That's time squared. So this can be written as, in diverse form, length per time squared, or length per time squared, or length per time squared. So all these are dimensions of what? Of acceleration. Then the unit will now be replace the dimension with the appropriate unit. Length is measured in meter, time in seconds, so this will be seconds squared. Remember, this is time squared. Or you can write it as meter per second squared, or meter per second squared. Wow. So we'll look at the fourth one, which is momentum. The fourth quantity, momentum. What's the formula for finding momentum? Because that's the first thing we write. Mass times what? Velocity. So momentum is mass times velocity. Okay? What's the dimension of mass? So we write the dimension of mass as m. What's the dimension of velocity? We have determined it here. Look at it as the dimension of velocity of this or this. So, but let's choose this form. So we have length over time. So m times this is m l over t, which I can write as m l per time, or m l per time raised to power minus 1. I've taken our time to explain this, that when we have this, when this time should come up, when this t comes up, it has negative power based on the laws of what? Of indices. So the unit now will be, unit of mass is kilogram, unit of length is meter, unit of time is seconds. Or you can write it as kilogram meter per what? Second. Or kilogram meter per second. So that's the unit of momentum. That's beautiful. That's beautiful. So we have one more to go. and that's force. So how do we find the dimensions and units of force? Let's do that together. If I will now give you some takeaway questions that you are going to solve. Yes. So let's look at this. The fifth one, we have what? Force. Force is mass times acceleration. Force times mass times acceleration, that's force. What is mass? M. What is acceleration? We found the dimension before. Acceleration is length over time square. So this becomes m times this all upon t square, which I can write as ml/t square or ml per t square. So what will be the unit of force now? Is going to be kilogram meter over second square. Mass is in kilogram, length is in meter, time is in second, or kilogram meter per second square, or kilogram meter per second square. But we have to note one thing. The SI unit of force is Newton. Is Newton. So 1 kilogram meter per second square is equivalent to 1 Newton. So when we do calculations, and if we calculate force, the unit we are going to insert there will be Newton. So you see that if you know the formula of a quantity and you have understood the concept of dimension and units, you can easily find the dimensions and units of derived quantities. Okay, let's solve these questions as takeaway questions. So take these ones away, solve them and send to me. You can send it as a message, or you can send it to our WhatsApp group. All right, so take away questions. Take away questions. So find the dimensions and units of energy, work, and pressure, given that one, energy is mass times acceleration times height. Then 2, work is force times distance. Then pressure is force over area. Okay, just do these 3 questions and then send the answers to me. In our next video, we're going to look at the corrections and then we'll now move further on other aspects of dimension analysis. Thank you for watching our videos. Remember, there is need for you to subscribe to our YouTube channel. Follow us on Facebook at Mathematics and Science Meal. And also, you can follow Engineer Ike Okechukwu on Facebook for more rough meals on physics, chemistry, mathematics, and biology. Thank you, and God bless you. I love you.